Welcome back. We are gradually building our knowledge in the advanced algebra tools. In this lecture, I'll introduce you to a new mathematical entity. It will look like a scary beast at first, but don't freak out. It's one of the most powerful tools in this field, the Livi-Civita notation. But before that, let's back to our new defined axis. The cross product, as we learned, between two parallel vectors equals to 0, and between two perpendicular vectors is 1. Therefore, the cross product result between our vectors will be 0 for a vector cross itself and the perpendicular vector for the another two vectors in the next case. We want to represent the cross product in index notation, like what we did before with the dot product. In order to do that, we must define a new mathematical entity. This entity is the Livi-Civita operator. The Livi-Civita operator is defined as it's plus 1 if there is an even permutation which are related by rotating the number around by starting from 1 to 3, then 3 to 1, then 3, 1, 2. And it's minus 1 when we start from 2, 1, 3, and we do the same permutation for 3 to 1, 1, 3, 2. And this is called the old permutation. And it's 0 if 2 or more indexes are the same. For example, epsilon 1, 1, 1, epsilon 2, 1, 2. From the definition, the Livi-Civita operator, the epsilon ijk ek is equal to the sum of epsilon ijk ek for k from 1 to 3. This is because if we substitute instead of k, I or j, we will get 0 in the Livi-Civita for the first two epsilons and 1 for the last one. From here we can write the cross product as the E1 cross E2 is equal to epsilon 1, 2, 3 E3 and the same thing for the another cross products between the unit vectors. Because E1 cross E2 equals to epsilon 1 to k ek, which equals to the sum of epsilon 1 to k ek, which is equal to epsilon 1 to 3 E1 cross E2. And the same thing is true for all the cross expressions. From the definition of the Livi-Civita, we can see that epsilon ijk is equal to epsilon kij, which is equal to epsilon jki. And the same thing for the odd permutation, but we will get there the minus sign. Now it's time to write the cross product in index notation. We can know that A cross B is equal to AI EI cross BJ EJ, which is equal to AI BJ EI cross BJ, which is equal to AI BJ epsilon ijk ek from the definition of the cross product with the Livi-Civita. The ith component of the cross product between A and B is equal to the summation of I, the summation of j from 1 to 3, because we are talking about the three-dimensional space on epsilon ajbk. And when we do the summation, there are 9 terms in the sum, but this time only 3 of them are non-zero. Therefore, we can omit the summation, and we got that it's equal to epsilon ijk aj bk. I know it's quite difficult to realize all these new mathematical definitions, but after a few practices, you will definitely be good on it. As you can see, the using of the Livi-Civita is for the cross product, and the using of the Kronecker delta is for the dot product. A very important identity and the relation between Kronecker delta and Livi-Civita operator is when we got two epsilons, epsilon ijk, epsilon ilm, it's equal to delta jl, delta km, minus delta jm, delta kl. This identity is so important, but absolutely you don't have to remember it. You can look at the indexes in the Livi-Civita such that the first index in both the epsilons are the same, then the indexes at the delta will be JL-KM minus the second one as JM-KL. A lot of new stuff, I know. Don't worry, you will be confident on it in the practice section. This is the hardest topic you will ever learn in vector algebra. Don't worry about it, just keep on and practice in the next sections. See you there.